Hi, today we have to do some problems related to the Taylor's and maclaurins series. What are the techniques for finding the Taylor series? These tables we have to study carefully. That is 1 by 1 minus x, this is 1 by 1 minus x, this is a function which we have to study carefully, and we have to study 1 plus x square plus etc. summation n equal to 0 to infinity x raised to n, and interval of convergence is -1 to 1, open interval -1 to 1. And what will be the Maclaurin series for e raised to x? 1 plus x square by 2 factorial plus x cube by 3 factorial plus etc. Summation n equal to 0 to infinity x raised to n divided by n factorial. Interval of convergence is open interval -infinity to infinity. And next is the Maclaurin series. Sin x is x minus x cube by 3 factorial plus that is the odd term. So we have to remember this Taylor series by using this odd behavior, right? So plus x raised to 5 by 5 factorial minus etc. In total, we can say that this is summation n equal to 0 to infinity -1 power n into x raised to 2n plus 1 divided by 2n plus factorial. And this is interval of convergence is the whole interval. And look at the next one, that is a cos x. Cos x is an even function, so we have to memorize this using this even property, that is 1 minus x squared by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. And this can be summarized as summation n equal to 0 to infinity -1 power n into x raised to 2n divided by 2n factorial. Okay. And look at the next example. That is a log 1 plus x. We have to study x minus x squared by 2. There is no factorial here. That is, we have to remember that x squared by 2 plus x cubed by 3 and the alternative term minus x squared raised to 4 by 4 plus etc. That is the summarized as summation n equal to 1 to infinity -1 power n -1 into x raised to n divided by n. And the interval of convergence is open interval -1 to close to 1. What about the sine inverse, tan inverse, and the binomial series? A sine inverse x plus x cubed by 2 into 3 plus x raised to 5 by 1 into 3 divided by 2 into 4 into 5 plus etc. This is its sum. And for tan inverse x, we can memorize easily x minus x cubed by 3 plus x raised to 5 by 5 plus minus x raised to 7 by 7 plus etc. Okay. Again, in the textbook, there are a lot of problems, so we can look through that. Find Taylor series representation of f of x equal to 1 by 1 plus x at x is equal to 2. This is actually a very important question connected to this university examination. So there will be at least 1 or 2 questions relating to this Taylor's and Maclaurin series for the university exam. So you have to study carefully. F of x is 1 by 1 plus x. I can write this as 1 by 3 plus x minus 2. I can take 3 outside. One way is we can do using f dash x, f double dash x, f triple dash x, and at 2 find the values and substitute it. Or another way is here. This is another way. So at x equal to 2 means we have to express this Taylor series expansion in terms of x minus 2. At x equal to 1 means we have to expand it, we have to find the Taylor series expansion in terms of x minus 1. Here we need the x minus 2 term, so 1 by 1 plus x is equal to 1 by 3 plus x minus 2. I have to convert this x into an x minus 2 term. So plus 3 minus 2 to same as 1 plus x. So no problem at all. So taking the 3 outside, 1 plus x minus 2 by 3, that is 1 by 3 into 1 by 1 plus x minus 2 by 3. Using the formula in the table 1 with ax replaced by minus of x minus 2 divided by 3, we obtain f of x equal to 1 by 3 into 1 by 1 minus x minus 2, and we know that 1 by 1 minus x is equal to 1 plus x squared plus x cubed plus etc. So in the place of x here, minus of x minus 2 by 3 is here. So replace x by minus of x minus 2 by 3 in the expansion of 1 by 1 minus x. So in the place of x, this is plus x squared, this term. So our expansion will be of this type. So in the place of x here, minus of x minus 2 by 3. So 1 by 1 minus x happens for mod x strictly less than 1. So mod x minus 2 by 3 strictly less than 1, that is mod x minus 2 is strictly less than 3, or x is lies in between minus 1 to 5. This is an easiest technique in order to find out the Taylor series or Maclaurin series. Find a Maclaurin series for f of x equal to x squared sine 2x. So sine 2x is equal to, we can say that what will be the expansion of the sine x, and we can replace this x by 2x. So sine 2x is equal to 2x minus 2x whole cube divided by 3 factorial plus 2x whole raised to 5 divided by 5 factorial minus 2x whole raised to 7 divided by 7 factorial plus etc. And we can expand this by using this term, and which is valid in minus infinity to infinity. So x squared sine 2x, what we need an expansion for x squared sine 2x. So substitute sine 2x as so the Taylor series expansion for the sine 2x in this equation. So x squared into 2x minus this term. So multiply, and after rearranging, we will get the sum as my summation n equal to 0 to infinity minus 1 power n into 2 raised to 2n plus 1 into x raised to 2n plus 3 divided by 2n plus 1 factorial, and which converges for all x in minus infinity to infinity. Okay, again we can go through one more problem. Find the Taylor series for f of x is equal to sine x at x is equal to pi by 6. The help to write of f of x is equal to sine x, and sine of x minus pi by 6 at x is equal to pi by 6 means we need an expression containing x minus pi by 6. So I'm converting this as inside this sine x minus pi by 6 plus pi by 6 sine of a plus b. What is sine of a plus b? Sine a cos b plus cos a sine b. So this is the term. So root 3 by 2, the cos pi by 6 means that is a 30. Cos 30 is root 3 by 2. Sine 30 is 1 by 2. After substituting this, and we know the expansion for the sine x and cos x. So sine x minus pi by 6 and cos x minus pi by 6. So we have to find out the expansion, and the substitute the expansion here. Then we will get the Taylor series for f of x is equal to sine x, right? In another way, this is not easy actually. This is not easy. So f of x is equal to the expansion for f of x is equal to sine etc. X is equal to 0 is very easy, but x is equal to pi by 6 is not easy. Okay, you have to see the difference between that two. Again, we can look through one more example. Find the maclaurin series representation for f of x is equal to sin hx. Sin hx is 1 by 2 into e raised to x minus e raised to minus x divided by 2. 1 by 2 into e raised to x minus e raised to minus x, which is equal to 1 by 2 into e raised to x minus 1 by 2 into e raised to minus x. And this is 1 by 2 into 1 plus x squared by 2 factorial plus etc. minus 1 by 2 into 1 minus x plus x squared by 2 factorial minus x raised to 3 by 3 factorial plus etc. After rearranging this term, we can say that summation n equal to 0 to infinity x raised to 2n plus 1 divided by 2n plus 1 factorial will be the series. Okay. Find the first three terms of the maclaurin series representation for f of x is equal to e raised to x cos x. And we know the Taylor series expansion, maclaurin series expansion for e raised to x and cos x. So we have to write these expansion and we have to multiply these expression, and we need to write the term one by one term after multiplying, and we will get 1 plus x minus x cubed by 3 plus etc. Look here, that is 1 plus 1 into 1. First of all, we have to multiply 1 with these whole term. 1 by 1 minus x squared by 2 plus x raised to 4 by 24 minus etc. Again plus x into this term plus x squared by 2 into this term plus x cubed by 6 into this term, and so on. Finally, we will get that 1 plus x minus x cubed by 3 plus etc. Find the first three terms of the maclaurin series representation for f of x is equal to tan x. F of x equal to tan x, which is equal to sin x divided by cos x, which is equal to x minus x cubed by 3 plus etc. How can you divide these? We can find, actually we know the expansion for the tan x, right? Using these sin x and cos x, we have to find out the series. How we can divide these, right? That is, we are going to look through. First of all, write these. Firstly, I have to divide this x. So here that is 1. So I'm multiplying this x. First I have to write this x only. So x into this term, that is x. That is here. X minus x cubed by 2 plus x raised to 5 by 24 minus etc. subtracting 1 by 3 x cubed. So 1 into this one means plus 1 by 3 into x cubed here. Again multiply this 1 by 3 into x cubed with these series and right here and subtract it. Right. Then we will get 2 by 15 into x raised to 5 plus etc. So 1 into 2 by 15 x raised to 5 is here. Here it is 1. So this is, we can directly write this term here. And so on. That is x plus x cubed by 3 plus x 2 by 15 into x raised to 5 plus etc. This is a expansion for maclaurin series for the tan x. We can also find an integral e raised to minus x squared dx using the Taylor series. We can this is a homework to you, and you have to find a power series representation for the sine inverse x, and you have to do carefully, and you have to do these two problems, and Srihari and Jisha, you have to study these example 14 and example 13. Example 13 for Jisha and example 14 for Srihari. You have to study, and you have to present that. Okay.